Hey everybody, it's Lon.TV. I am not an AI influencer, but rather a tech creator who likes to find affordable ways to get things done with technology. And the other day, of course, we heard about the Deepseek AI model that came out of nowhere and disrupted the tech industry in a big way. The big disruption here is that their model is very efficient and it runs on hardware that is not as robust as what OpenAI and Google and other big models require. So that was a big development. And I think for us who are looking to play around with technology on the cheap, there's some great opportunities here because now we're going to see a race for efficiency. How efficient can we get these models? Can we get useful models running on gaming laptops, for example? And that is going to be the subject of today's review. We're going to install one of the distilled versions of this Deepseek model on this computer. We're going to run it locally, so we don't need the internet to do it once everything gets downloaded. And we'll see if this Lenovo Legion 5 laptop with an NVIDIA 3070 GPU and 8 gigs of video RAM will be able to do some useful local AI that's not too slow and can also spit out some results that I might be able to do something with. So we'll take a look at all of this in just a second. I do want to let you know, though, of course, in the interest of full disclosure, that this is my personal laptop that I paid for with my own funds. All of the opinions you're about to hear are my own. No one has reviewed or approved what you're about to see, and this is not a sponsored video. Additionally, I am not an AI expert. I am a generalist, and I was able to get this working on my gaming PC upstairs, and I'm going to follow the same steps here to show you how I'm going to get it working on this laptop. There might be better ways and better tools, and I welcome your comments down below, and maybe we'll do a follow-up as things continue to evolve. So let's get into it now and see what we can get running on this laptop. Now we're going to demo this today on Windows with an NVIDIA GPU. This will work on Linux and Mac computers as well. You'll have some differences in how you get things installed, but I think the conventions here should be the same across the board. Now, because we have an NVIDIA GPU on this laptop, I'm going to start by downloading NVIDIA's CUDA Toolkit. What I found on my computer upstairs was that I was running with the standard gaming drivers, and the app we're going to use to access the AI models was not seeing the GPU. After I installed this, it worked. So we're going to start with that. So that is downloading. And after we get the NVIDIA Toolkit installed, we'll move on to getting Llama, which is how we will integrate the models onto this computer. All right, so now that we have the NVIDIA tools installed, we can get Ollama installed, which is how we interface with these models. This is actually really easy to install. You just download it, select the operating system you are downloading for, and you can go ahead and get that running. So we're going to let that download, and I will install it, and once it is installed, we will take the next step. Now, Ollama is actually run from the command line, so what we're going to do is go down here to search and just type in CMD and hit enter to get that up. And if I just type in Ollama here, you can see that it's ready to go. But what we have to do first, though, is pick out a model to download. So let's see how to do that. So back on the Ollama.com website, you'll see an option here for models. And when you click on that, you can see what models are available to you. We will try one of the Llama models, which is the open source model from Meta. But first, we'll choose the Deepseek one that we want to install. So if I click on Deepseek here, what you'll get is a little bit of information about what's available and how to install it. But what we want to do is see what models we can actually run on this computer. So the full model requires 404 gigabytes of memory to run. I don't have that kind of option on this laptop, and many of us don't. But if you look here, there's a bunch of distilled models with different numbers and a B after them. So for example, the one that I'm going to try first here is 8B, which is 4.9 gigabytes in size. The 8B stands for 8 billion parameters, which is how many parameters it uses to try to infer what you are asking it to do. So of course, the more parameters, the better it performs. And the one that, again, runs on their big server with all that memory is 671 billion parameters. So what we're going to get here is nowhere near as good as what you'll get online through a data center, but it's going to get better, I think. So we're going to do the 4.9 gigabyte one and select that. And if we drop down here, you can see what the command line is to get it working. So it says Ollama run Deepseek R1, and what we need to do is look for the 8B one here so we don't download the big one. And I'm just going to copy that, and I'm going to paste it into the command line and hit enter. So what this is going to do is actually go out and download the full 4.9 gigabyte model. And then when it's done downloading, it's going to run it immediately right here in the command line. Now you could also just download the model by pulling it. So instead of run, we could put pull in there, and that would just download it and not run it. But let's take a look and see how it works. So let's let this download, and when it is done, we will first check to make sure that it's using the GPU, and then we'll ask it some questions. Okay, so the model is done downloading, and it's ready for a command here. It says send a message. And what I want to do first is just make sure that we've got the GPU properly configured here. So if I hit Control-Shift-Escape to get up my task manager, and I go over to performance, I can see that 6.6 gigabytes of the GPU memory is in use, which means that we've managed to fit this entire model inside of the GPU memory, which is what we want for the best performance. So now I'm just going to ask it a question, or just ask it to say something. So we'll say, hey, I am shooting a YouTube video and you are the star. Anything you want to tell the audience? And we'll hit enter here. And what's neat about this model, the Deepseek one, is that it actually tells you the thought process that it's doing when it goes to make a response to you. So what we saw here is that it puts up this little think here, and it says, all right, the user is asking me to be the star of their YouTube video. That's pretty cool. And so normally this is what would happen in the background of a ChatGPT session, for example. It does all of this without showing the user. Here, this model kind of shows you its work in coming up with a response. And here you can see it said, hey everyone, I'm excited to be the star of the YouTube video. It's got emojis going on there and all sorts of cool stuff. Maybe we can have it tell me something about YouTube stars, and we'll see how fast it goes. But you can see just how quickly it's generating this text, and this is one of the things that I've been most impressed with this Deepseek model. Is I'd never seen this performance on mere mortal hardware before, so that's pretty cool. All right, so now that we got that working, why don't we try a different model, this one, the Llama model from Meta, and let's see how fast a similar size model responds on this hardware. All right, so to get out of the chat, what you do is hit /by, and that will drop you back out to the command line here. But this doesn't shut down the model. So as you can see here, we've got our full GPU memory still in use. So we actually have to go and stop it so that we have room for the other one that we're going to download. So what we're going to do here is, instead of Ollama run and the Deepseek model, we're going to say Ollama stop. And what this will do is shut it down, and you can see immediately our GPU memory usage has dropped right off. So now, why don't we find a different model that we can install of similar size, at least insofar as parameters are concerned. And as of the time of recording this video, Llama 3.1, which is from Meta here in the US, has an 8 billion model here with about 4.9 gigabytes in size. So that's roughly the same size as what we were just playing with here. So what we're going to do is have it go and download that one. So what I'll do here is just select that 8B again, and what we should see over here is the command to run in our Ollama app. So I'm just going to copy that to the clipboard. I'm going to run back to my command line and just paste that in and hit enter. And like before, it'll start pulling everything down, and then it will give us a prompt. So why don't we let this download, and let's see how fast it is asking it the same questions that we did on the last one. All right, just to keep things fair here, I've got the exact prompts I made before in Notepad. I'm going to copy that. Now we're running Llama, and as you can see, our GPU memory is pretty much in the same spot we were before, about 6.6 gigs consumed. I'm going to paste in that prompt here and see what it does. So here we go. So actually the speed here is pretty similar, and I guess it might be just due to the parameter count. And it looks like we get a very similar response from that particular chatbot, Llama. And we'll just have it give us a little bit on YouTube stars here, and I'll paste that in, and you can see what it comes up with. So, you know, not a bad response here, and it gave a very different output for the second question, a little bit more lengthy than we got on the other one. All right, so now that we've got these models installed and working off of the GPU, let's take it to the next level here and give us a nicer look to the whole experience. We're going to install something called Open WebUI, and this will give us a ChatGPT-like web interface that we can use through our web browser, which will make these easier to use and also make it easier to work with some code challenges we're going to give to both of these models in a minute here. So why don't we get this installed? Before we do, let us get out of the chat here and shut things down so we can free up some memory. We don't need to have everything running here in the background. And we'll stop that, and we will get this going. Now to start here, this does require that you install Docker on your machine. To my surprise, Docker Desktop works just fine with this on Windows. So why don't we get Docker installed. After that installation, we'll get Open WebUI installed, and then we'll connect it to our models here. It's not as hard as it sounds. All right, so for Windows here, I found the easiest way to get started is using Docker Desktop. This is also available on other platforms, although Docker is probably a little more efficient to install on the command line for Linux and Mac. And what I'm going to do here is just select the AMD 64 Windows version, and we'll download that into my downloads folder here, and we'll get this desktop Docker installed, and then we'll take a look at the next step. All right, so we got to the end of the install process, and I'm just going to click on the skip button here asking for the login, because we should be able to get in here without having to register for anything. I'm just going to say that I am a student here, and we'll click on skip and just get out of this. So now we've got the Docker desktop here running, and what I'm going to do now is go back to the Open WebUI page, and if I scroll down, they have a Docker installation option. So we have Ollama running on our computer, so we're just going to grab this, and we're going to go back to the command line here and paste it in. And this will actually work. I was surprised because typically I haven't had very good luck with Docker containers on Windows, at least for the things that I've played around with. But as you'll see in a minute, this is actually going to work. What it does do is it reserves port 3000 for this web interface that we'll connect with through the browser. So if you have something that uses port 3000, you'll have a conflict. You'll have to go in and just change the command line to a different port, which you can do right over here. So why don't we let this container finish installing. When it is done, we will now have a shiny graphical user interface to work with our models here. All right, so if we go over to our Docker desktop, you will see that we've got everything running. If I click on this link, this will actually take me over to the WebUI that is running inside of that Docker container. And if we just click on Get Started here, we just have to put in our name and email address and a password, because this does have some password protection for authentication, but it's all local. So let me get that set up, and then we'll log in and access our models. So now we've got everything going here, and I can choose which model I want to chat with. So for example, right now it's defaulting to Llama that we installed earlier on our Ollama application, but instead here I'm going to select the Deepseek one. If I had more memory, I could actually have these run side by side, and you can see which one performs better. But because we're filling up most of our GPU memory, it wouldn't be a fair comparison, given that one of them would end up getting tossed over to the CPU and onboard RAM. So here we are. We've got basically what we've typically seen on a ChatGPT-like environment. So let's see how well this Deepseek model can do a little bit of coding. And what we're going to do is have it generate a Space Invaders game with this prompt that I've created. So what we're going to have it do is create kind of the basics of what the game is about. You can read it on screen here. And I want it to compose everything into a single HTML file. Again, we're going to do this all locally using this distilled Deepseek R1 to do it. So we've just submitted the request, again, all running locally here. And the thinking is happening. And of course, we can click on this link here, and it'll give us its thought process about how it's going to go about creating this game. I really like this. It's kind of fun to see how these models work and what they're thinking about in trying to infer what your request is. And now it's spitting out the code. So you can see the speed in which it's generating. What I'm going to let it do is finish. I'm going to copy this into a HTML file, and then we'll run it and see how it looks. All right, it is done, but things didn't go so well. So as you saw, it was generating code a minute ago, and it gave us a full HTML file, and then it got a little crazy. So at the end of its code here, it started putting out its thought process again, and then it generated a bunch of Python code here. And the end result in a single HTML file, which was what my request was this, which doesn't quite look like Space Invaders. So we may need to go back and have it redo its work, this time using solely JavaScript and nothing else. And this is what I've been noticing as I've been playing with this, is that it's not very good because of the limited parameter count at guessing what you're trying to get it to do. I did change the prompt slightly to have it do the JavaScript and the single HTML file here in the first paragraph, but the result was this, an orange block that doesn't do anything. So I think this smaller model may not be well suited for these types of coding tasks, but let's keep exploring a little bit further. Now, I did ask the larger model that I have running on my gaming PC upstairs, the 14 billion parameter one, to do the code, and it did a little better. But as you can see, this is not much of a Space Invaders game. It basically is impossible to play it here. So not doing all that great so far. And if you look on the request here, it started off in English, no problem. In fact, most of its thought process was in English. And then when it generated the code at the end, it started spinning out Chinese. So of course, this is a Chinese model, but there is a lot of hallucination going on here, both with this larger parameter one and the smaller one, as we saw earlier. Let's see if the Llama model can do any better with this. All right, so the Llama one did its thing. It didn't take all that long, and it gave us some code. So there you go. I used the very same prompt we used before. And this is what I got. It's not much of a Space Invaders game because nothing seems to really work. But it is a little bit more Space Invaders-like than what we saw out of the other model that we were playing with a second ago. But what happens if we use something a little more robust? Well, a little bit earlier I gave ChatGPT 01, which is running, of course, on a big data server with many billions of more parameters. And what it gave me was a very functional Space Invaders game here on the first shot. So I can move left and right here. I can use my space bar to fire. It keeps track of collision detection here as well. So much better on the first go. And I think this is the difference between what you can run at home versus what you might be able to run in a data center with a lot more resources available to you. But I'm not done playing around with this just yet. Maybe these distillations are better at language. So why don't we give it a language task real quick before we close out. All right, next I'm going to give it a task that I do with ChatGPT all the time, which is to take a video transcript, which I just pasted into the chat window here, and turn it into a blog post. I use this to write my posts on my blog at blog.Lon.TV. I usually do a lot of rewriting and reworking, but I found that it's a real time saver if I can have a structure to start with without having to reinvent the wheel every time. So I give it the transcript, and ChatGPT usually does a great job with it. So why don't we start off here with Deepseek R1, again, the $8 billion parameter distilled one. And what we're going to do is send the text up to it locally here and have it chew on it and give us what I hope will be a blog post in a narrative format that I can work with. So it's going to be thinking about it here. And as you can see, it'll put up its thought process if you click on this. And now it is done thinking, and it's presenting what it came up with. Unfortunately, this is not something I can work with. Although this is a summary, this is not what I asked for. I asked for a narrative blog post, and instead I got just kind of a summary outline of what it did here. I did try to change this prompt a little bit a few times before I started going through this take, but it really wasn't giving me anything different than what you see here. Now, if we jump over to ChatGPT, you can see that it gets it right on the first time. It has many more parameters that I think better guess at what I am looking for. And what it spits out is something that is very detailed and something that I can work with as a start of a blog post based on what I sent into it. But I did go back and ask the model here, the Deepseek one, a few more times to give me something in paragraph format. And it was really a matter of getting the right combination of words in the prompt, which then led it to create something that, although is not as good as the ChatGPT output, it is fairly close to what the transcript was saying. It stuck to the order of things. It didn't hallucinate anything. So it actually did a passable job for a local model in putting this together. And I will say, in fairness, that the outlines that it came up with were also pretty close to what the transcript required. I do, though, see myself doing a little more work with this one to get it right. Now, I also ran it on the Llama model from Facebook, and initially that one gave me the same little outline thing that I didn't want, and then I gave it the same corrective prompt here, and then it came back with a narrative that I think is actually a little better than the Deepseek one. So Local AI here is getting really good, I think. It's still not anywhere close to what you would get with a big data center model, but I think both of these examples here, Llama and the Deepseek one, are showing that as things get more efficient and these models get more and more refined, it's probably feasible that you'll be able to get a very nice distilled model that is very good at one particular type of prompt. So I don't think it's out of the realm of possibility that we might see some very usable local AI in the very near future. And that's one thing that I'm kind of excited about with this DeepSeek thing, is that it's really going to push everybody to get more and more efficient. And what I'm seeing running on this laptop has really surprised me, especially given what we saw just a few months ago running on this very same piece of hardware. So lots of progress is being made. One last thing before I close out, if you want to stop all of this stuff, one of the nice things about the OpenUI is that it will open and close the models as needed, so it just doesn't leave them in RAM like you saw before off the command line. And if you want to shut everything down, just pull up that Docker desktop app and hit the stop button, and that will shut down the UI that we were playing with, and you can go back to playing your games on your laptop there. Now, if you don't plan on running this all that often, you might want to uninstall Docker. And that's because Docker does put some libraries into memory that run in the background, even if your local GUI is not running. So just getting rid of Docker will take care of that, and you can always reinstall it when you want to play with these models again. So lots of great progress here. Hopefully this was helpful if you are an AI beginner like me to try to mess around with these things a little bit. I think you'll be surprised by how far they have come. That will do it for this one. Until next time, this is Lon.TV. Thanks for watching.